So imagine you're holding a deeply sobering daily newspaper in your left hand.
Right. Yeah.
And the headlines are just heavy, right? They're detailing the very real human cost of these widening military conflicts, casualty reports, critical global shipping lanes being completely choked off.
It's grim.
It really is. But then imagine your right hand is resting on your laptop, and that computer is actively updating with, the most advanced, massive digital brains ever created by human beings.
It's an intense split screen.
Exactly. It's this dizzying split screen of reality. So welcome to today's deep dive. We're pulling from a pretty intense stack of military briefings, global market data, and latest AI release notes, all from March 28th, 2026.
Right, to really unpack how these two physical realities are basically colliding right now.
Yeah, our mission today is to look at that collision.
Yeah.
Because, it is a profound contrast to process.
Oh, absolutely. On one side, we're looking at a very fragile, very constrained physical world, right? And on the other, there is this seemingly unbounded explosion of digital capability. But, and this is the key, that digital world isn't just floating in the ether.
Right, it's not magic.
Exactly. It is fundamentally tethered to the physical world. And, the stress fractures in our global infrastructure are really starting to show.
So let's start with that physical reality, because the human toll of what's happening in the Middle East right now, it really has to ground everything else we talk about today.
Yeah, we have to start there.
We're looking at the latest data from Operation Epic Fury, and, the numbers are stark.
Yeah.
U.S. Central Command confirmed 13 troops have been killed and 303 personnel wounded.
And when you read the actual details of those injuries, it paints a very, very grim picture of modern combat.
Yeah, it's not just abstract numbers. We're talking about traumatic brain injuries from blast waves, severe burns, and shrapnel wounds from these advanced missile and drone strikes.
Right. And those casualty numbers, they've actually doubled just in recent weeks.
Doubled. Wow.
Yeah, which tells us a whole lot about the intensity of these localized engagements. And the geographic footprint of this conflict is expanding rapidly, too. It's no longer confined to just a single border.
No, not at all. Because Israel has announced a ground incursion into southern Lebanon, right?
Yes, aimed at establishing a northern buffer zone. And that maneuver coincided with the targeted killing of Iran's Navy chief.
Which is a massive escalation. We are seeing waves of missiles and drones triggering air raid sirens as far as Tel Aviv.
Exactly. But the ripple effect is also moving outward into areas that affect international logistics. Iranian missiles and drones have now struck port infrastructure in Kuwait.
And that broadens the scope far beyond just Israeli and U.S. military targets.
Right, because now you're hitting global trade.
Exactly. When port infrastructure in Kuwait is hit, you are striking at the commercial logistics that the rest of the world relies on. And there was also that footage of a U.S. F-18 fighter jet having to physically evade a missile over Iranian airspace.
Yeah, that was wild to see.
It really shows how highly volatile and multi-front this whole situation has become. The airspace itself is contested, which, brings us to probably the most critical physical choke point on the planet right now.
The Strait of Hormuz.
Yeah. Iran's Revolutionary Guard has declared the Strait of Hormuz closed amid the ongoing U.S. and Israeli bombing campaigns that are targeting Iranian nuclear sites and export terminals.
And for our listeners, the closure of the Strait of Hormuz is really the fulcrum point for the global economy.
It really is. And diplomatically, the timelines are incredibly compressed right now.
Yeah, you have Secretary of State Marco Rubio saying the war might be nearing an end without an immediate ground invasion.
Right, suggesting the focus is heavily on securing Iran's uranium stockpiles.
Exactly. But simultaneously, President Trump has extended an ultimatum deadline to April 6th for Iran to reopen that strait.
And that came with an explicit threat, right?
Yeah, the threat of striking Iranian power plants if they fail to comply.
So we have these two distinct diplomatic messages, both pointing toward a very, very tense April.
Definitely.
So for the person listening to this right now, when we see a conflict spreading to Kuwaiti ports and Lebanese borders in real time, how does a physical closure of a waterway like the Strait of Hormuz immediately ripple out to the rest of the physical world?
Well, the Strait of Hormuz handles roughly 20% of the entire world's oil trade.
20%? That's huge.
It's massive. It is a narrow channel, and when you basically put a cork in it, the energy markets react instantly. The market data shows Brent crude surged over $110 a barrel.
Right. I think it specifically hit $112.57.
Yes, 112.57. That is an 11.6% spike in a very short window.
And the equities markets absorbed that shock immediately. I mean, Wall Street had its worst single-day drop since the early days of the COVID-19 pandemic.
Yeah, the sell-off was brutal.
The data shows the S&P 500 dropped 1.67%, and the NASDAQ fell 2.15%. And, we aren't here to editorialize the market movements or take political sides on the conflict, but those are the raw numbers.
Right, it's just the reality of the situation. It reflects a massive repricing of energy costs.
Because energy is the baseline cost for literally everything else.
Exactly. And this is where we connect that newspaper in your left hand to the laptop in your right hand.
Yes, let's make that connection.
We talk about artificial intelligence and, the cloud as if they exist independently of physical resources. Like they're just floating up there.
Right, like they're weightless.
But AI data centers require massive, continuous base loads of electricity. When global oil spikes, natural gas and broader power markets feel the pressure immediately because you have to burn fuel to generate that electricity.
Right.
So when physical power infrastructure is actively being threatened in military ultimatums, like we just talked about, the baseline physical cost to keep the servers running for our digital infrastructure just skyrockets.
Yeah, I think we really tend to visualize the cloud as invisible, but really it's a very thirsty, incredibly power-hungry factory.
Thirsty is a good word for it.
Right. To train and run the AI models we're seeing today, you need gigawatts of power. You need cooling systems that require massive water and energy resources. So when a tanker literally cannot get through the Strait of Hormuz, the cost to power that data factory goes up.
The digital boom is fundamentally tethered to the global energy supply chain. You just cannot separate the cost of a barrel of crude oil from the cost of computing power.
Which makes the timing of these new tech releases feel almost surreal.
Oh, completely.
Because despite this massive pressure on the physical supply chain and the energy grid, the AI labs are just accelerating. They're not slowing down at all.
No, we are officially in the era of the trillion-parameter push.
Yeah, so let's look at the release notes for DeepSeek V4. They just released this as an open-weight model with a staggering 1 trillion total parameter.
And a context window of over 1 million tokens.
Exactly. So let's define those terms for the listener, because the scale here is, well, it's difficult to wrap your head around.
It really is. So a parameter is essentially a microscopic connection within the AI's artificial brain. It's a piece of knowledge, or like a learned-it relationship.
Okay.
Having 1 trillion of them means the model has an incredibly vast, nuanced understanding of language and logic.
And what about the open weight part? Because that seems significant.
Yeah, open weight means the company isn't locking this technology behind a paid proprietary interface. They are releasing the actual architecture, the trained neural network itself, out into the public for developers to download and use on their own machines.
Wow. And that 1 million token context window you mentioned.
Right. So that means you could hand this AI a stack of books, literally thousands of pages of text, and it can hold all of that information in its working memory at the exact same time to answer your questions about it.
That is insane. And they aren't the only ones doing this, right?
No, not at all. Alibaba just shipped their Qwen 3.5 series with 8 different open variants, scaling all the way up to a 397 billion parameter model.
And Mistral AI just dropped Mistral Small 4 under a highly permissive Apache 2.0 license.
Yes, and that Apache 2.0 license is crucial here. For our listeners, that's not just boring legal trivia. It means developers can take this frontier-level model, modify it, and commercialize it without paying royalties or facing heavy restrictions.
So they're basically handing out the blueprint to a supercomputer for free.
Exactly. The ecosystem is flooding the zone with these massive models right now.
Okay, I have to push back on the strategy, though.
Go for it.
If the physical supply chain is breaking down and energy grids are under extreme macroeconomic pressure because of the Hormuz closure, isn't dropping a 1 trillion parameter model incredibly irresponsible in terms of power consumption?
It's a fair question.
Like, how can anyone even afford the electricity to run that right now?
Well, it sounds like a paradox, but the software architecture is actually adapting to these physical constraints. DeepSeek V4 has 1 trillion total parameters, yes, but it uses something called a mixture of experts, or MOE architecture.
Okay, break down how MOE solves the power problem.
So think of a massive corporate office building. You have 1,000 highly specialized experts working there.
Right.
If you ask the company a single question, you don't need all 1,000 experts to speak at once to give you the answer, right?
No, that would be chaos.
Right. You only need the 3 or 4 specialists who actually know about that specific topic. MOE works the exact same way. Out of that 1 trillion parameters, only 32 billion are actually active during inference.
And inference is the moment it's generating an answer for you.
Exactly. It routes your prompt only to the relevant experts inside the neural network.
Ah, I see. So they are engineering their way around the brute force energy problem. By only waking up the parts of the brain needed for the specific question, they keep the actual compute costs, and therefore the energy footprint manageable.
Yes, despite the terrifying headline size of 1 trillion parameters.
It is a brilliant workaround. But even with architectural tricks like mixture of experts, you still need the physical hardware to run these things at scale, right?
Oh, absolutely. You cannot run a 1 trillion parameter model on a standard laptop. You need highly specialized silicon.
Which brings us to the next major development in the release notes. Cerebras is integrating their CS3 systems onto Amazon Web Services' Bedrock platform.
Yeah, this is huge.
The notes emphasize a disaggregated architecture. Which, I mean, that sounds like heavy engineering jargon, but the mechanics behind it are actually fascinating. They are taking Amazon's proprietary Trainium chips and pairing them with the Cerebra's wafer-scale engine.
And to understand why this pairing is revolutionary, we have to look at the mechanics of how a large language model actually answers a prompt.
Okay, lay it out for us.
There are two distinct phases. The first is the prefill phase. That is the model reading and processing the huge document or prompt you just gave it.
Right.
The second phase is decoding. That is the model actually generating its answer word by word or token by token.
And normally, a standard GPU is trying to do both of those jobs at the exact same time. It's sort of like a chef trying to prep all the ingredients and cook the meal simultaneously.
Exactly. It creates a massive bottleneck.
So Cerebras and AWS are separating the kitchen duties.
That is a perfect analogy. They use the Amazon Trainium chips to handle the heavy lifting of the pre-fill reading phase, the prep work. Then they hand off the decoding, the actual cooking and generation of the response to the Cerebra's wafer-scale engine.
And the wafer-scale engine isn't a normal computer chip, is it?
No. It is essentially an entire silicon wafer, roughly the size of a dinner plate, packed with processor cores.
Just visualizing a single computer chip the size of a dinner plate is wild. Why make it so big?
Because the memory and the computing power are all physically located on one giant continuous piece of silicon. It doesn't have to send data back and forth across a motherboard through tiny wires.
Right, which slows things down.
Yeah, here the data travels microscopic distances, which means the speed is just blistering.
The release notes state this setup delivers token throughput 5 times higher than conventional GPU setups. 5 times the speed.
It's a massive leap.
But, getting back to our physical reality, how do you manufacture and deliver a dinner plate-sized piece of flawless silicon?
Well, you rely on one of the most complex physical supply chains in human history.
Exactly.
To build that wafer, you need neon gas, you need rare earth metals, you need advanced packaging facilities spread all across Asia, and most importantly, you need global shipping lanes to move the final servers to data centers in the US or Europe.
You need the Strait of Hormuz to be open. You need the Red Sea to be secure. The data centers waiting for these Cerebras machines are relying on the exact same maritime security that is currently unraveling in the Middle East.
Precisely. A disruption in global shipping fundamentally threatens the hardware supply chain required to run this entire software race.
Right.
If the commercial logistics out of Kuwait are hit, or if a shipping container of advanced chips has to reroute entirely around the continent of Africa because the Middle Eastern corridors are closed, the deployment of this technology slows down and the cost of the hardware just goes up.
It feels like the tech industry is building this massive, highly tuned V8 racing engine in these Cerebras systems, while the global gas station is literally on fire.
That's a great way to put it.
The physical world is constricting, but the digital demand from these AI labs is entirely inelastic. They just keep pushing.
They keep pushing because the capabilities being unlocked right now are moving way past just novelty. We are transitioning from chatbots that write emails to autonomous agents that execute complex workflows.
Right.
The economic value of that transition is just too high to pause, even when the supply chain is under severe pressure.
Let's talk about those autonomous agents, because the specific tools dropping right now are going to change how you, the listener, interact with your computer. OpenAI just launched GPT 5.4.
Yeah, another massive release.
It has a 1 million token context window, but the headline feature is native computer use for agentic workflows. And then Minimax released M2.7, which is specifically targeted at software engineering agents.
This is the shift from tell me a recipe to do my job for me. Let's look at Manus. an autonomous AI research agent that was just released.
Yeah, Manus is fascinating.
You don't just chat with Manus. You assign it a multi-step research brief. You might say, go do a competitive analysis on these 5 companies.
Right. Think about the most tedious part of your own job. Now imagine assigning that task to a software agent on a Friday afternoon.
Exactly. Manus plans the workflow, executes the web searches, synthesizes the data. It even realizes if it made a mistake, goes back to fix its own error, and has the final report waiting for you by Monday morning.
Without you ever lifting a finger or staying in the loop.
Yes. Or look at Cursor, the new AI coding assistant. It is context-aware. That means it looks at your entire software code base, not just the single file you happen to be typing in.
Which is huge for developers.
Huge. You can describe a bug in plain English, and it understands the complex relationships across your entire system to rewrite the logic. Developers are handing off the repetitive plumbing of software engineering so they can focus entirely on high-level architecture.
But then there is the frontier that feels almost like science fiction. Meta just released Tribe V2. And this one really made me pause.
Yeah, Tribe V2 is a foundation model, similar in underlying structure to a language model, but it is not trained on text or code.
No, it's trained on over 500 hours of fMRI brain scan data from hundreds of different human participants.
Right, and it can predict brain activity to visual and auditory stimuli in a zero-shot setting.
Let's clarify zero shot for the listener. That basically means the model wasn't pre-trained on your specific brainwaves, right?
Correct. The AI has never seen your specific brain data before. But if it knows what image you were looking at or what audio clip you were listening to, it can predict how your brain will fire.
Why?
Across different languages and different human subjects, it has essentially mapped the universal patterns of how human brains react to stimuli.
So we are seeing models like Meta's Tribe V2 actually predict human brain responses. We are racing to automate and digitally map our own thinking processes just as the physical world demands our utmost attention. It's quite the paradox.
It really is. While the physical world is engaged in territorial warfare, maritime bottlenecks, and resource constraints, billions of dollars are focused on simulating cognition and physical reality digitally. Just look at what is happening in robotics right now with world models.
Right. Companies are using gaming data and simulations to train robots rather than physical environments.
Exactly. Rather than putting a physical robot in a physical room and having it bump into walls to learn how to navigate, developers are training action-conditioned world models.
Okay, so what does that mean in practice?
The AI internalizes the laws of physics, gravity, momentum, friction within a latent digital space. It is building its own internal physics engine to practice in.
Because the real world is simply too volatile or too expensive to train in.
It comes down to constraints. If the physical world is constrained by supply chains, expensive energy contracts, and geopolitical chaos, the most efficient place to train a robot is inside a perfectly controlled, entirely simulated digital universe.
Man, we have covered incredible ground today.
We really have.
To summarize this for you,
Yeah.
you are living through a very specific historic moment. We have a fragile, deeply physical reality marked by the stark human casualties of Operation Epic Fury, the closure of the Strait of Hormuz, and oil spiking past $112 a barrel.
Yeah.
And that reality is putting massive infrastructure pressure on the hardware supply chains and data center energy grids required to power our technology.
It is a stark reminder that the digital world is inextricably bound to the physical one.
Absolutely.
The massive compute required for these trillion-parameter models and the intricate supply chains needed to build those dinner plate-sized silicon chips. They rely on the very resources and shipping lanes currently caught in the crosshairs of global conflict.
So the next time you sit down and use an AI tool like Manus to research a project or Cursor to generate some code, remember? You are tapping into a physical infrastructure that is tied directly to the price of oil and the security of global shipping lanes.
It's not just invisible code floating in the cloud.
No, it is electricity burning in a data center. It is silicon shipped across oceans, and it is geography. Which leaves us with one final thought to ponder.
Let's hear it.
If an AI model can now simulate the physical world for robotics and even predict human brain activity using fMRI data, could a trillion-parameter model eventually map out a solution to the very supply chain logistics and energy crises threatening its own hardware existence?
Oh, wow.
Or is it destined to simply consume those physical resources until the grid taps out? Imagine holding that sobering newspaper in one hand and that updating computer in the other. Which one ultimately writes the future? Something to think about. Thanks for joining us on this deep dive.